Okay, I'm today here with an easy concept, I would say, and that's differentiation. So I will cover some examples that would cover all the principles of differentiation. And yeah, so to get started, I'll get with this example. So if you have y equals 3, and that's just a number, so what will be, okay, before that, so differentiation, if you have something y equals, let's say, some function, you denote differentiation as dy over dx, and this means differentiate y with respect to x. Okay, so now I have y equals 3, and 3 it's a constant, and I want you to differentiate dy over dx, and you can't see a x here. So if you are to differentiate a constant like this is a constant. If you differentiate a constant, you will get 0. Is that clear? Okay, so that's the first thing you should know. If you differentiate a constant, then it's 0. Moving on, so that's like the basic of differentiation. And now I'm going to add an x to the equation I wrote initially. So that's y equals 3x. And again, I want you to differentiate this with respect to x. So I want you to differentiate y with respect to x. So dy over dx, and that would be 3. So I would explain this as this. So if you have something y equals ax, what is the power here? It's 1, right? So every time you differentiate something like this, it's always y equals na. So imagine I have n here. So I bring that n to the front. So when I bring that n to the front, so when I differentiate, I bring that n to the front. So when I differentiate with respect to x, I bring the n to the front. And then it's ax, I write it as it is. And then I reduce the power by 1. Differentiation is always reducing by 1. You learn integration later where you increase the power by 1. So that would be nax n minus 1. So here, if I write it in that format, it would be, what's our n here? It's 1. So you bring 1 front. And then you have a, that's 3. And you have x and 1 minus 1, right? So 1 into 3 into x to the power 0. So x to the power is anything to the power 0, it's 1. So 1 into 3, and that's 3. So if you have a constant and an x value to the power 1, it will be always equal to that constant. Okay, so imagine you have it like just y equals x. Now you should be able to simplify it. Yeah? How are you going to do it? So if you follow the same principle, what do you have in front of y or in front of x? You have 1. You have 1 here. So your differentiation dy over dx will be equal to 1, because why? If I show it like this, here you have 1, you bring 1 to the front, and your a is 1, and again 1 minus 1, so here x to the power 0, that's 1, and so 1 into 1, 1. Okay, so this is the basic of differentiation. Moving on, so I hope this part is clear, where you differentiate simple linear equations, and then moving on to differentiation of power functions. So imagine your function is like this: y equals x to the power n. So this is an example I discussed here, but here n was 1, right? N was 1. So the same principle basically. So if you have x to the power n, when you differentiate, you're supposed to bring the n to the front, and that will be dy over dx. So that's the first step. Bring n, the power, to the front, and then you write x just like that, and you have n minus 1. Okay? Cool. So moving on, what if you have a bigger function? How are you going to do it? So imagine you have a function like this. So if you have a function like 2x to the power 5 minus 3x squared plus 5 over root x. So the first step you're going to do is you're going to write everything in the format something ax to the power n plus bx to the power n, like all the n's, all the x's in one line instead of denominators and numerators. So how do you do that? You bring the x at the denominator to the numerator. So it's simple indices. So 2x to the power 5 minus 3x plus 5. So x root x is x to the power half. So when you bring it up, it will be the negative of the power. So it will be 5x minus half. And now you're going to differentiate it. So how are you going to differentiate? Now I have not equated this to y or anything like that. So but I will be differentiating this with respect to x. So you can write it like this. Okay? So just how I explained you to do differentiation with power functions. So you do it just like that. So you bring the 5 to the front. So you differentiate this part separately, and this part separately, because these are additions and subtractions. So basically you're adding some simpler functions and subtracting some simpler functions to get a larger function. So if you differentiate this part, it will be 5, 2x, 4. Yeah, and here minus 3 because it's x, and plus here you bring minus half into 5x, and minus half minus 1 would be minus 3 over 2. Yeah, and this would be 10x to the power 4 minus 3 minus 5 over 2 x to the power minus 3 over 2. So this is the differentiated function. Okay, so this is the basic principles of differentiation. And moving on, there are 3 rules for differentiation, and they're namely chain rule, quotient rule, and product rule. So I will discuss the chain rule, product rule, and the quotient rule in the next video. So to conclude this, I forgot to mention something. So differentiation is why is differentiation important? You can use differentiation to find the gradient of a function, and that is like the main purpose of differentiating a function. Okay, so if this is my function, and then this is my gradient. Okay, so if I want to find the gradient at, we'll say gradient at x equals 1, then you have to plug in 1 to this equation. Okay, make sure you plug in to the differentiated equation and not to the initial equation. Okay, so yeah, don't miss my next video because I will be explaining you the chain rule, product rule, and the quotient rule, and that's the whole a very big part of differentiation, but yeah, it's a simple one. So do watch that video. Thank you for watching, and do subscribe and thumbs up. Thank you.